with no further ado, we're going to proceed to our first event of today. We're very lucky to have all three authors of AI-powered search, the forthcoming book from Manning, three of the world's leading search experts, and they're going to come and do our Ask Me Anything session. If you have a question, obviously put your hand up, I'll come and find you. We also have our online attendees, hopefully have some questions for Doug Turnbull, Trey Grainger, and Max Irwin. Please welcome to the stage our panel. Stump the Chump.
Raise your hand if you've been to, remember Lucene Revolution, Stump the Chump. Yeah, that's what this is. So, except we're not going to be able to answer any obscure, like, how do I do X and weird thing in Solr? We're more the Stump the Chump about AI and machine learning and search. So,
yeah. So, do we have a first question for our panel? Is nobody quite awake enough yet? Oh, Stavros, right.
I have a very broad question, and I hope to get an encyclopedic response. I hope you'll do better than ChatGPT. LLMs are fantastic. They're impressive. Is there a good way to keep up with the various ways people are using LLMs in search? I mean, you've presented some of them in your talk yesterday, Trey. How do you keep up with people's ideas? Because there are lots of great ideas of how to take advantage of them.
I mean, we can all take it. The way I do it is just on like social media and forums, and I like have to just constantly consume information and see what's interesting to me. So the two main places that I find out stuff are on Relevancy Slack. So if you're not part of Relevancy Slack, be there. There's a new generative AI channel on Relevancy Slack. So hopefully we'll start getting more interesting stuff in that channel. And then there's, like, I found out a lot about the stuff on Hacker News, which is kind of a weird place, but if you filter out all of the nonsense, there's some really good stuff that gets posted. A lot of state-of-the-art things and ideas go there. And just also finding stuff because I'm trying to use them, and then like researching on the latest archive papers and stuff like that, and you know, I'll do searches and things like that and see if anything, you know, hits my keywords or my vectors.
So question, those of you in here who have semi-kept up with what's going on with ChatGPT and, you know, AI and what have you, raise your hand if prior to the conference you were reasonably familiar. Most of the room. Okay, perfect. Raise your hand if you feel incredibly overwhelmed with all the information coming out. Basically, more hands. So there's a couple of challenges right now. One, there's a massive amount of hype. So obviously, ChatGPT is phenomenal technology. It's wowed everybody. It didn't come out of nowhere. You know, GPT-3 has been around for a while. You know, prior GPTs, other models, the stuff's been in development for a long time. It's just finally hit that wow moment. And there's a lot going on. If you look at, you know, after ChatGPT came out, you know, when Llama came out, you know, there's issues with licensing. So Alpaca came out. After Alpaca, you've got variants of that, like Koala, you know, some other ones, but they all have licensing issues. If you try them for some uses, the way some of them have been trained, they appear to be about 90% as good as ChatGPT on a wide variety of questions, but you can't use them commercially. So now people are going back to T5 Flan, tried to use that as a base, you know, train it, see if they can get closer to what ChatGPT offers, GPT-4 at this point. You know, there's the GPT for All project that's really, there's just so much going on. And I think AutoGPT, I didn't mention yesterday during the presentation, but you know, imagine taking, if you're not familiar, AutoGPT or Baby AGI, if you take those models and you, like GPT, for example, GPT-4, you put a while loop around it and tell it, generate your own prompts, come up with your own ideas, execute them, then come up with the next idea. You basically just put a while loop around it. Now you've got GPT-4 thinking. I'm using that, quote unquote thinking, however you want to define that. But you've got it going in a process of essentially brainstorming, daydreaming, going down different paths, doing research without a person having to actually direct it. And that's amazing and terrifying at the same time. But all of these things are going on, and AutoGPT, within like a week, maybe 2 weeks, had more stars on GitHub than PyTorch, which has been around forever and is actually underlying a lot of these technologies in terms of how people are implementing them. So both the excitement and the hype, and the Google Trends, if you look at the numbers, they're insane right now, which means two things. One, there's a lot of interesting innovation going on. Two, there's a lot of hype going on. And three, there's basically no way to keep up right now. And so the question was specifically about about search and how do we keep up with how these are being used in search. And we have been talking about dense vector models for years. 3-4 years ago, I was speaking about this at what was Lucene Revolution, now Activate, speaking here at Haystack. I think that using tools like the Relevancy Slack and just within this community, I think that that's a really good idea to talk about specifically how these things are focused on search. But the reality is, even writing the book, right? Like the last chapter of the book, I've now revised 2 times, worked with Max on some of it, and I finally just said, screw it. I'm going to put something decent there that talks about using the model, some of the stuff I spoke about yesterday. But then I'm going to go finish the rest of the book, and then the very last thing before this is published, I'm going to make some edits. And because there's literally no way to keep up. Like some of that information will be out of date in a week if it's specific to specific technologies. And so my general view is focus not on the specific technologies, but focus on the general idea, the design patterns for solving these problems. And then at that point, you just plug in whatever the best available technology is at the time. So I think dense vector search, focusing on fine-tuning, focusing on training, focusing on thinking about vector spaces and multimodal search and hybrid search. I think these general design patterns are correct and are evolving. But I think in terms of the specific technology, I don't know, ask me tomorrow, I'll have a different answer than today.
Yeah, I think in general, like, it's similar to how we keep up with anything, except the hype curve on this is like extremely massive. Yeah, it's like way up, and I'm just like, maybe we're gonna crash way down, and we'll figure out the right way. But often with these things, when you looked on like LinkedIn, as a heavy LinkedIn social media user, it's really hard to separate the signal from the noise. There's just so many people posting about this stuff who are like, do you really, like, is this something you know about? Are you generating the hype? Is this marketing? There's also like sort of a lot of vested interest in driving a hype curve right now. There's venture money looking for a place. There's the job situation for a lot of people are shaky, so people are going to jump on a hype curve and try to make the best use of it. And so how I always approach these things, regardless of GPT or whatever, I wait for people I trust to see what they're doing with it. And I sort of say, oh, that's interesting. You did this thing, and it seemed to help you in this specific way. And eventually sort of patterns emerge that you can sort of hang your hat on of how a tool can be used. And that's sort of like over time, and it's going to take time for the hype curve is kind of like what is like the trough of disillusionment, and then what is the end of it where people realize how the tool should be used, like its right niche. And that's kind of how I figured that out. It's like I rely a lot on people I trust to sort of see what they're doing and interesting things that they're doing with this technology and ideas they have to sort of approach things. And at a high level, it seems like there's some patterns that, like, and Trey mentioned this in his talk, of like, oh, we use search as kind of complementing chat by injecting context into the prompt, or chat is driving search. Like, there are these like high level patterns, at least from a user experience point of view, that seem to be emerging. And another sort of high-level pattern I think Trey mentioned in his talk is like generating content that might then be used to seek the right answer from a search index. It's almost like a more like this kind of thing, or either more like this or vector search or both. But yeah, I'd say like don't upend your roadmaps necessarily. That's sort of my advice to most people. Like keep plugging away at the sort of bait and tackle sort of meat and potato stuff that you need to do for that a lot of people are still tackling like really low hanging fruit.
Fantastic. That's a great start. So thank you, chaps. We have a question from somebody also regarded as a bit of an expert in this field, our Finnish correspondent, Mr. Dimitri Khan, who firstly says that he's been very happy to have both Doug and Max on his Vector podcast. Do check out Dimitri Khan's Vector podcast. It's awesome. And he hopes to interview Trey soon. Get the full set. So his question is, where do you believe the sparse search versus dense search story is going? You know, are they going to converge in some kind of holistic search engine, or will both approaches continue to exist separately?
I'm already holding the microphone, so I'm going to talk. All three of us, by the way, if you give one of us a microphone, we'll just hold on to it forever. So we're going to be fighting over this thing all day. Is it not on? Hold it up to my. Okay. Yeah. First, I got to figure out how to use the microphone, and then we can. So I think for me the term that I've seen used a lot during this Haystack in particular is hybrid search, talking about sparse and dense vectors. So we were actually having a nice little conversation this morning before the conference started about best practices for what a real search, I'm sure a search experience looks like. And all of these pieces have, I don't know what's going on with the microphones.
Take this one out.
Okay. All right. Oh, wow, that's way better. So I think all the pieces have their place, and they all add up to something better, right? Sparse versus dense. You talk about BM25 or vector search, if you're familiar with those terms. But there's a lot of other things that add up to a great search experience. And really what it's about, and a lot of the book is about a lot of these pieces that you have to kind of put together for a mature experience. So it's really you take signals from a lot of different places, and you take them and then you put them in a re-ranker. So you'll have BM25 on various fields. You might have a vector search on various fields. You'll have like ratings or recency or all kinds of stuff, and those become features, and then you re-rank them. And that's really hard to do. It's really complicated to do that because now you have to worry about a lot of different things working correctly. You have to worry about a lot of different data being cleaned, labeled, in good quality, and then there's a lot of like narrow tuning of each part, and then there's the tuning of the bigger part, which a lot of things can go wrong during that process, and it's really complicated. But that's really where I see all of these things happening, is like part of a bigger, mature platform. And then that's really, you get the best stuff to the top, and then what we were just talking about before with, having generative AI is like, if you give generative AI like not great stuff, you're not going to get a great summary or an answer to your question. So you really have to give it the best stuff to the top, and then that's like the seed for, a generative process that does something with that. Rock, paper, scissors for the mic.
I think one thing that I think about sparse versus dense, so traditional search systems and vector databases, I feel like we are moving away from, if you look at how like Bing and search engines are evolving, you just see more and more how, depending on the type of query people are running, and query now could mean prompt, there's just a radically different system that's driving that behavior depending on the use case. And we, before the GPT craze, we would see this with like, oh, you're obviously doing you're doing a certain search that's like a few keywords, and there's a strong title match and an exact keyword match, and maybe that's a good, like, sparse sort of like keyword matching use case. And then maybe we have more of a natural language query, and that gets redirected to a different system that's actually built for a question answering. It's going to give you one answer, and the UX is going to be different. Or I'm searching a specific person's name, and I'm going to get the info box for that person or that known entity. And I feel like more and more over time, just like being able to recognize the intent of the query and route it to the right system that solves the problem well is more and more important, especially as these things evolve. And I think like that's kind of the direction search is going. Like nobody is expecting 10 blue links necessarily anymore. They're expecting you to understand them, present an experience that solves their problem, and the ingredients to that experience can be radically different. So generating code is very different than putting in some query syntax into the browser or into the search bar and getting like site : this, title : that with a bunch of mandatory terms. So I think our jobs are only becoming harder. And I remember when I wrote Relevant Search, this was a point I made, is like a lot of people think the user experience is the things you click on, but more and more the user experience is hidden in these algorithms and how we understand queries and these back-end systems that answer the questions. And to some people, that's been invisible, how you make that a great user experience. And I think we are seeing a bit of like, people do realize this, but there is a bit of like, oh, I just put it in this system, it gives me an answer, and I trust the answer because it came from this smart search engine and it must know what it's doing. But I think that's like as practitioners, that's something we always have to fight against. So.
I'm going to piggyback on what Doug said for a second. I think there's two levels of thinking about search. So the question was about sparse vector versus dense vector search, which is more of a technical question, I think. But I think we have to determine what we mean by search, and then we also have to determine it's sort of like what is the goal of the technology, and then we have to think about, from an implementation standpoint, what does search do and what does search do well from a technology standpoint. So tackling the first one, kind of going to what Doug was saying, I think, as far as I can remember, we've always said the goal of search is to meet a person's information need, to fulfill their information need. So historically, we had a bunch of data. We brought them back data and said, here, you go analyze it, figure out if this data is any good for you. We'll do our best to give you the right data to go explore. Going forward, obviously, we're talking about answers, summarization, and some of the sort of thinking and research happening instantly for the person before they get the results. And going beyond that now to not just, because I would argue, here's some code that does what I'm asking is meeting the person's information need. We're searching for information and bringing it back to them. Do we want to define that as part of what search is? I don't see why not, but I have arguments with colleagues who aren't from the IR space, and they're like, no, search is just like, you put something in a box, and then AI is all this other stuff. It's a false line to draw. We can figure out, if we want to define search as meeting the user's information need, well, now we just have a lot more tools to help us do search better. Or if we wanted to say, no, search is only inside of the sphere, that's fine, and we'll figure that out as an industry. But when you go beyond that to, hey, I want you to go book me tickets at the theater. Well, there's a search component to that where you're finding the information, finding the theater, finding the times, but then there's actually taking actions. Back when I was at Lucidworks, a lot of our customers took those actions on their enterprise data, and the search engine was actually able to go out and make API calls and do things. So is that part of search? I don't know. Where do we draw that line? Separately, though, zooming back from what is search and how does it differ from AI and what's the overlap, I think there's the technical questions. And we all know historically, search engines operated as inverted indexes. The reason for that is because it's incredibly inefficient to go out and scan all of the documents and try to find answers in real time. You need lightning fast responses, and so an inverted index that pre-indexes the data before the request comes in so that it can effectively return it instantly or do set intersections and return it quickly was really important. As we move into this dense vector world, obviously, if you have a flat index and you're doing cosine similarities with every single document in an index, that's incredibly inefficient. Well, that's the problem that search technology initially tried to solve. And we do have solutions to those problems. So we talk about ANN approaches like HNSW, but there's also other approaches like hashing-based approaches. So like learning to hash, for example, is more or less mapping the multidimensional vectors into a hash that you can index, which means you can search on it like a term. You can find things. You can do a Hamming distance on it, which is incredibly efficient from a computational standpoint. Many CPU architectures have built-in instructions to do that specific operation, which means that solving the problem technically, when we think about dense vector search versus sparse vector, it's not really about is it dense vector search versus sparse. It's really about how can you most efficiently get as much recall and then rank to get the best results using underlying data structures. And so I would argue that one more thing, just definitionally, and this is somewhat academic, but what I was showing yesterday, where I was showing an inverted index modeled as a vector, like a one-hot vector with just a single keyword in place. That is a sparse vector. Even if there's millions and millions of dimensions and most of them are 0, sparsity refers to how many of the features have values, not is it big or is it small. Similarly, a dense vector just means that most of the values are filled in or a large portion of the values. And so doing what I was just referring to, for example, with learning to hash and having a hash, that hash can represent a dense vector with all of those dimensions, but just be a really tiny thing that you can match on really quickly. And so I think the line between what is a dense vector, what is sparse, are we doing hybrid, I think in reality from a technology standpoint, what we're going to figure out as a field in search is how to do dense vector searching incredibly efficiently like we use an inverted index to do with keywords. And I mean, I think Search Hub did that. They were acquired for that specific reason, for that technology, because it made it lightning fast. I think the general idea, though, is the problem is well understood and solvable. So I think from a high-level standpoint, what is search? How do we define it? I think we have to tackle that as an industry. But from a technical standpoint, right now we're doing a lot of inefficient things and having to talk about hybrid models when in reality, I think the underlying data structures might make some of that kind of go away over time.
Fantastic. Thank you so much. And thank you, Dimitri, for your question. Now, we've suddenly got a forest of hands. Fantastic. So I'm going to start by going to the back. Who do we have up here? There we go.
I have a very simple question, and it has a very simple response. Trey, could you please share your slides today?
Could I? Yes.
Wonderful. Okay, so who else do we have? We had sorry, I'll come to you, Yuri.
Hey. Quick question regarding personalization. In most search engines, if I run a query and you run a query and we are located in different places, we get different results. What is your take on personalization in modern search engines?
Yeah, personalization guy.
I'm personalization guy?
I'll take it.
Okay. I am generally, it depends. It depends on the type of query. So my take on personalization is related to a take on understanding user intent. So if a user intent comes in and it's ambiguous, and we might want to diversify the result set to capture many possible intents, then we may know something about the user and say, we'll give a slight tweak towards this. So geo is like, I'm not sure I count geo as, when I think of personalization, I'm not necessarily thinking of geography. So I feel like that's kind of, if I search for a restaurant name and it comes up that, you know, it's not going to show me the one in Spain, it's going to show me the one in Charlottesville. That's one thing, but that kind of gets to the general idea of like, if I type something and it's ambiguous, what do we know about the user? To kind of like just give a little nudge towards one intent over another. And if we think about this, like one way to think about this is to look at query refinements. So let's say I search for something really broad like shoes, and I notice that there is a group of people who tends to go to, next they type dress shoes, next they type sneakers, next they type like Crocs. And that's what they query refinements. That's like what they change their query to, right? And we notice some patterns of like who tends to go in one direction versus another. So we know shoes, people often see the results and then they decide, oh, I want something more specific. Those almost, in a way, hint at intentions within that query that is too broad. And those hint at ways, first and foremost, and this is the first thing people, I think, need to tackle for those broad queries, how do we diversify over those sub-intentions? And then two, and this is why I think personalizations maybe like sometimes like ... like a bit farther down the line. How do we, if we know a little bit about this user, oh, maybe they're fit and they might want tennis shoes, or they buy, I don't know, they buy running shoes every 3 months, or they're dad and they wear Crocs with socks like I do. Then maybe there's a bit of a reason to put, instead of the Crocs in position 2, put the Crocs in position 1. But when you get to very specific queries that are like, like a very like specific intention where it's like very unambiguous, in my opinion, I don't think there's much of a role for personalization. So.
So Doug mentioned personalization being a nudge. I very much agree with that. I use the word light touch when I'm referring to personalization. So to give you some concrete examples, so I'm actually writing the personalization chapter now for AI-powered search, be done hopefully in like a week or two. But for some concrete examples, let's back up and ask what the goal is. The goal is to meet user intent. If I have somebody who's, say it's a job search engine, they're running a search for Java developer, and they're in San Francisco, we don't want to be showing them Java developer jobs in London, most likely. Maybe that person's interested, but we definitely don't want to be showing them jobs in Moncks Corner, South Carolina. Nobody's ever heard of that, probably. Maybe like 2 people in this room. So I think, I grew up there, so I can make fun. So I think that the important thing is to understand their context and to only bring them back results. You know, ideally, you're showing them all Java developer jobs, but you're ranking the results closer to them better. Same thing if somebody just runs a search for San Francisco and they're a registered nurse, you don't want to be showing them biomechanical engineering jobs. You want to be promoting things that are related to registered nurse. That's a form of personalization. I used to work at Career Builder, so I'm using these career examples. One thing we used to do is when people would run searches, we would figure out where they were applying to jobs. You know, is this person applying to jobs only within a 5-mile radius of somewhere? Or is this a person applying to jobs in major big cities in this country? Or is this person, looking at, so we could sort of figure out, are they looking at big cities? Are they small town? Are they close by? Do they have a wide radius? And then use that as part of the recommendations, but also in terms of the ranking. And so that's also a form of personalization. It's geo-based. It's not a filter per se, but it's understanding, what they're looking for and helping to surface those types of things. I'm doing, in the chapter, an e-com example, and it's interesting. So imagine somebody goes and runs a search for microwave. They see like kids pink microwave, or maybe like there's like a Hello Kitty microwave in our data set. And they say, and then they click on, no. They click on a stainless steel microwave made by, I don't know, LG. And then a couple moments later, they search for range, and they click on an LG stainless steel range. And then they search for refrigerator. Intuitively, you would say, hey, if there's an LG stainless steel refrigerator, why don't we show that at the top of the results? And your intuition would be right. If they then go and search for sunglasses, that doesn't necessarily mean they want stainless steel sunglasses, right? If somebody searches for Avengers Age of Ultron, and we show them a DVD, that doesn't mean that, you know, when they search for the next thing, we should be pushing up stuffed animals for, you know, Avengers characters. And so there's also this notion of, when I say light touch, there's this notion of understanding neighborhoods and clustering. So what we do in the chapter is we say, hey, we're going to take all of the data in the ecom index. We're going to generate dense vectors for those based upon the content. We're then going to create clusters around all of that content, categories basically dynamically generated, and then we're going to determine how close each of those clusters is to each other. And if somebody takes an action, for example, they've clicked on something that in its vector it has the notion of stainless steel, it has the notion of a brand, and then they search for something in a very close by cluster in vector space, close by neighborhood, then we're going to apply that vector, you know, and the closer it is, we're going to apply it more. And if you get beyond, you know, maybe 10% in terms of the distance from the overall vectors, we stop applying personalization altogether, because that's a different type of product that shouldn't have the personalization information carry over. And so that's like a strategy. But I think the important thing is, when somebody searches for something, you don't want to just change their search results to be based on things they've searched for in the past. What you want to do is look at the session that they're operating in, look at the context in which they're operating, and if you have some highly salient information to that session and to that context, potentially use it to boost a little bit, but maybe even only do it for one or two results, not for all the results, just so you're sprinkling in some personalization as opposed to like taking over their search results.
I just wanted to point out one thing that I think about with personalization and is really important, that I think maybe we don't talk about it a lot, is that it really depends on when we're talking about search, like search is like everywhere, right? So there are a lot of domains that we can apply things to. I think e-commerce, maybe, you know, looking for jobs, things like that, that's a great aspect or domain that you want to apply personalization to. There are other domains that you might want to stay away from, because you might make assumptions about the person using it that's wrong, and that could be maybe not bad, but just like you might be giving them the wrong information in a critical situation. Like, you know, if you want to, if you're working on like law or health or things like that, you know, what you recommend in the search like carries more risk than it would if like somebody's shopping for something, because the information you give them is important in different ways. So just when you approach technologies like this and you make assumptions about users and what information you're giving them, just be careful in certain situations.
Thank you. Can we have the mic on again? Yeah, thank you. So we're going to go to an online question now. We've had a few come in while it's been going on. Also, just extra points to Doug for saying it depends. Once a consultant, always a consultant. Okay, so Dave DeBar asks, is there any utility in using query embedding as features for learning to rank? Think of the embedding dimensions as a form of query classification scores, a step short of matching the query embeddings to document embeddings.
If I understood correctly, I think we talked about that a little bit. Having, you know, a similarity on a vector, and that's a feature for learning to rank. Yeah, absolutely. And I think this is, you know, a big part of a mature platform that uses a lot of different signals, and a cosine similarity, or, you know, some other similarity of a dense vector search will be part and will be a signal in a bigger platform that has a lot of different signals that will learn to rank. I definitely think it's important, and the way that you implement learning to rank, you know, it'll learn which signals are more important in different situations. Like short queries, it might realize, hey, BM25 is way better in this situation, so I'm going to go with this signal, and it's going to be great for like 1 or 2 term queries. But then you get like, you know, a 7-word query or a 10-word query, and it's like, hey, vector search is a lot more accurate over here, so I'm going to boost these results because of the vector similarity. It learned that's a more important feature for those use cases.
Yeah, just one thing I think is a bit of a complexity with embeddings. Yeah, you could take a cosine similarity as the feature itself. Sometimes these dimensions might interact with some of the other features in ways that are non-linear. So you take a cosine similarity, you lose the information that's in the vectors themselves when you go to evaluate the model. But let's say you were able to, I don't know, just as a hypothetical, in a traditional like lambda mart model, could you reduce the dimensionality to even just 4 dimensions or some small amount and treat each of those as a feature and see how they interact with the other features? Or even step further, that's why embeddings are input to deep learning models. But I do think like the interaction between sort of structured features, like more things like especially e-commerce like price and that kind of thing, and these sort of like similarity cosine features is something that gets quite tricky and complicated, and that's where you want to see sometimes how these subdimensions are interacting with these structured dimensions. Because one thing about search, it's very non-linear. It's not necessarily, oh, we just find this score and everything is always ranked on this perfectly linear like relationship between all the features. So.
Okay, so let's have one more question from the floor. I'm going to come up to here. I'm trying to balance this between the rear and the front of the room. Sorry. Doug.
I was wondering if you could address precision in large language model metrication. One of the things that I'm really struggling with right now is we have a long history of understanding and, in the 10 blue links, really metricating the hell out of that. We know exactly what's going on in those engines. When we turn it loose in large language models and we come back with 6 recommendations, it's just pretty much thumb in the wind at the moment. Do you have any advice or any thoughts on where that's going or how to evaluate that, or better still, how to compare that with more determinative processes?
That's a really great question, because a lot of vector search is about recall that we've seen. I've specifically been working in my own personal research trying to understand this problem, because understanding the difference between a positive and a negative is very, very difficult when you have a lot of words and you have events, and then you have a vector on both sides that represents a really complex part of a document and a really complex information need. So understanding if you're wrong is really, really hard to do. So I'm going to say I don't really have a great answer for that. But aside from just doing the work and labeling data to improve the model, that's really all you can do. You have to have a lot of queries that are labeled somehow. One thing I've been experimenting a lot with recently, and this goes back to the LLM stuff that we were talking about earlier, is trying to have like a teacher-student model to automate some of this, where you have a huge model that knows a lot more about the world than a little model that you might deploy in production for dense vector retrieval, and try to understand the relationship of, well, if this large model can tell the difference between a good positive and a good negative, then maybe it can teach this smaller model, and I can automate some of that. And I don't have to have a whole team of labelers to do the tedious work to understand these things if we have a really good teacher. And I'm really stuck on this problem because it's really, really hard to do, and I'm getting mixed results depending on my prompts and which direction I'm going. So I think this is a really interesting area for search, because we all talk about judgments, right? And judgments is like the thing that we know is like, this is what we measure search quality against. And it's gold. It's a golden set, we call it. So how can we help relieve the pain of generating a golden set? Because it's really, really hard to get that. And that's a lot of expertise and knowledge embedded in that. So if we can help that process and shortcut some of these things, then our search will be way better, and we can do a lot of other interesting things and work on more interesting problems. It'll free up other people to work on more interesting stuff than clicking on good or bad or whatever, because not a lot of people want to do that. So that's my convoluted answer to your question.
I might say, I'm not sure I'm convinced anyone has a good answer to this question right now. We're all just like, obviously we should use chatbots, right? And that's part of the hype curve. But I do think one interesting thing to look at is if you're in a domain where accuracy or the accuracy of the information matters, I think where we're going is a system where we get a chat response that cites its answers. And what I would look for is maybe I might think about a model that has kind of two measures. A, is anything substantive in the response cited? And B, are the citations accurate? So is what the chat claims the citation says accurate in what the citation actually says? And that points at sort of some kind of retrieval quality, like our retrieval system was able to accurately map a passage to a citation, and then some quality of coverage of like however we define like a substantive statement in the chat response. And I would feel better about that. I mean, I use ChatGPT. I get like programming answers. Sometimes I know they're wrong. I try them out. But I sort of, as a consumer, I have that sense of like, it might work 80, 90% of the time. And then occasionally it's just like, for whatever reason, I'm just going to go Google the docs or whatever. So, yeah.
Okay. So we're going to go to another online question. Right. There's a question from Bogdan here. Are there any reasons to use Solr still in 2023? I'm not going to dive into that thorny and horrible topic. I'm sorry, Bogdan. We're going to talk a bit more about AI-powered search. But Amrit asks, this might be controversial, would extractive information retrieval have any significance going forward now that generative information retrieval is pretty accurate in most scenarios?
The second half of that question, I question. About generative being pretty accurate in most scenarios. I think the general issue is that why are Doug, Max, and I up here right now and not a random person off the street? The answer is because we have experience. Maybe you trust us. I don't know. As experts in the field, these models are learning from data. They're not experts, but whatever data is out there, they're learning, they're representing, they're pulling back. We know, for example, ChatGPT and these other models hallucinate. And the question is, how do you verify that what they're telling you is true? So I know some people that go to ChatGPT with basically every question they have. They take the response, and generally speaking, they believe it, and they don't really do additional research. That's foolish, because you can have very well-written responses that are 80%, 90% right. They sound right. They're very compelling, but they're not correct. And if it's a domain you don't know about, you may not care about those nuances. But if it's a domain you care about, those nuances really, really matter. And so I think being able to relate information back to its source is important, but I think it's going to become more important over time. As we see, images, we're going to have the question, is this a real image or is this a made-up image? And we're going to want to be able to track it back to the original source, to the photographer, to the artist, some way to verify it. There's some use cases for things like blockchain technology and things like that for tracking, origination and sort of like the proof of origination. But even with that aside, with just information, I think that being able to say, hey, this came from this scientist who is known to be an expert in the field, or this scientist who is generally believed to be a quack, or this journalist who has a book out that is very controversial and they're trying to promote their book, or this random my name is Bob. I live in a basement and eat pizza every day and play video games. Acting as an expert on, quantum mechanics, for example. Like you need to know who the source is to be able to validate the credibility in making the claim. And I think that just assuming that what's coming from these language models is accurate because they have access to lots of information isn't fair. And maybe these models will be able to do some of that for us. But I think that as humans, and as people who need to be critical thinkers, it's important for us to be able to go to the sources ourselves and validate them and weigh sort of the likelihood of the validity of the information based upon where it's coming from. And so that's not a technical answer to the question, but I trust the models to help me find information, but not to determine what I think about the information. And I think that most people should do the same.
Yeah, I think it's a great question, and honestly, we don't know the answer for a while. But I will, so one controversial counter question, is anyone who's not a developer using ChatGPT? And I don't know the answer. Oh, there you go, we got one. Two hands, okay. Yeah, how many people are not developers? Yeah, so I do wonder about how do you, when you think about the user base, how many people are going to adopt this? Maybe it's huge. Maybe a lot of non-technical people adopt it. But I feel like, I don't know if it was Renee who said, like, maybe we have a bit of a solution looking for a problem sometimes. Maybe there are cases where people are happy with what they're using. That set aside, that is an open question. I don't know the answer to that, like where and how and to what people this will be used. The second thing is, in my own subjective experience, I treat ChatGPT as one pillar of when I'm doing software development. I go to ChatGPT, I say I describe a problem, I treat it as my personal Stack Overflow, I ask a question, I get a starting response, maybe a little bit of code to start. It doesn't work, or it's kind of not working. And I use Google to find I use Google for finding things about the topic. And why would I want things about the topic? There's a couple of reasons. A, I want other people's subjective experiences. So Stack Overflow post comments, what is upvoted? What are people, Reddit posts, what do people think is important here? ChatGPT is a very encyclopedic voice. ChatGPT is very much sounds like you're reading Wikipedia. It's not gonna be able to give you some sense, like Trey said, of authority, or of community, or of any of these things. I might want to know, what is the community doing about this? Are there bugs out there actively written about this? And all of these things. Maybe chat gets to the point where that's useful, but a chat interface that's doing that is basically gonna end up running a search to say, oh, yeah, there's people talking about this issue, here's a GitHub ticket, here's a Stack Overflow thing, and that lets me explore further. The third point I want to make is all of these conversations about ChatGPT are really focused on one class of information need, and that is informational. That's typically the domain of question answering and that kind of thing, where yes, obviously it's a huge benefit, but there are so many kinds of information retrieval. There's known item lookup, there's e-commerce, there's all kinds of ways people search. And to the conversation earlier, we're just gonna have so many systems that give different experiences based on the type of the query. And it's all an experiment. We're gonna see how it works out. And we don't even know how to evaluate this stuff yet. And we're learning. So yeah, maybe a lot of web search heavily integrates this stuff, but I have a hard time seeing a way, at least, that ChatGPT itself doesn't have search under the hood doing something. Oh, and there's also in context. We need to be able to search to give the context to the chat. So there's going to be a database of information we need to provide for that. So,
okay. So we've just got time for one more question. So I'm going to try and get one more from the room. Yes, you've been waiting there, so in the middle. Sorry we couldn't get to everyone. Obviously, we had limited time.
If you have a question that we don't get to answer, just come up to us during a break or something. We'd love to talk about this stuff.
I had one question, and then you started talking about personalization, and now I have a different question. One problem that y'all didn't touch on with personalization that's becoming more and more prevalent is we as search engineers and people who build search engines, I mean, Twitter uses our search, Reddit uses our search. How do we measure and draw the line between personalization and bias, where we put people in bubbles and it's like, oh, they really love this stuff, so let's personalize for them, and now we're creating bias in their little world? Or and how do we combat that in this like flow? Because it's something, we're not just all e-commerce. Like we gotta figure this out.
That's an amazing question, and it's kind of what I touched on when we were wrapping up the personalization question before. Maybe I'll be controversial in saying that I think personalization is like a type of like architected bias. Like you are specifically biasing the results towards a small set of people or even one person. So I don't know if I can distinguish the two. And that's why I mentioned, in certain domains, like it carries a lot of risk because you're injecting bias. Is it safe? Is it right in that situation? I think you have to make a judgment call on that. And, everybody here who's delivering information to people, we have a lot of responsibility. And it's different if, we can go and debug, a BM25 result and say, well, this should be at the top, and, we can change things and tune things. But when you're targeting individual people, you lose sense of the scale, and you can't fix a problem for one specific person if you've got millions of people using a platform. And that becomes a big problem, and then it's kind of out of your hands. So I think a lot of social media and stuff like that, like they've been grappling with these problems for years, and there isn't an answer to that question. If there was an answer, somebody would have solved it, I'm guessing by now, or maybe they will in some horizon. But I personally don't really distinguish the two. I mean, personalization is maybe a more friendly word for bias because bias has a lot of connotation. But that's what I think about the problem.
Yeah, I think, I really quickly, I think is just, teams often focus excessively, I think, on near-term conversions and success, and not, there is a fallacy, I think, of focusing on what's easy to measure, not what's important. And yes, conversions are important. These kinds of things are important, and obviously, they drive success for the most part. And when someone has a goal for the quarter of increasing something, it's hard to take a step back and say, my goal is also not to do this bad thing and somehow protect the brand and do these things. And then you have to be brave enough to make those calls that are sort of like, in some ways, often outside the data, because the data tells sometimes a very narrow and specific story.
So the word bias is an interesting word to apply to search. So I work for Presearch. We're a web search engine. A lot of conversations we have are about having unbiased search results, or at least some of our competitors want to have unbiased search results. There's no such thing as unbiased search results. In data, there's always bias. Whoever wrote the article has some bias, whether it's cultural, it's not, every piece of data is biased. And the whole purpose of search is to rank results so that you're seeing a subset of the results and preferring those results. That is bias. It's just that historically we've outsourced the biasing to the algorithms. So for BM25, it's biasing based upon the word occurrences, what have you. So we don't think of that as much as bias, but bias is just there. The purpose of the search engine is to bias the results towards the user's information need. And personalization is specifically biasing them more towards that user versus a generic algorithm applied to everybody. And yeah, you can certainly create problems. We mentioned nudging or a light touch with personalization. I'm personally a fan of not personalizing every result in the list, but maybe one or two of them and the top few results. With recommendations, typically we put it off to the side so we don't distract from the main search results. So I think making sure we don't, that the search is trying to be helpful without taking over and forcing the user down a particular path is important.
Okay, thank you so much. I'm afraid we're going to have to draw this to a close, but I'd like to please give a huge round of applause to Doug Turnbull, Max Irwin, and Trey Grainger.
Thanks, guys.